All, I would like to thank the organizing team for giving me this opportunity to present our work in this International Day of Women in Statistics and Data Science. Thank you. So here is our work, test for symmetry and confidence interval of the parameter mu of skew-symmetric Laplace uniform distribution. Myself, Vaijayanti Ullas Dixit from Statistics Department, Mumbai University, India, and my co-author Raju Lohot, he is my PhD student. So this work is regarding the skew-symmetric Laplace uniform distribution. This is constructed using the Azzalini's idea of 1985. This idea is the formula of this is 2 times fx k times lambda x, where f is PDF symmetric about 0 and K is an absolutely continuous CDF such that the corresponding PDF K dash is symmetric about 0. Now, using this F as standard Laplace and K as the distribution function of uniform over minus theta to plus theta in this formula number 1, we construct the skew-symmetric Laplace uniform distribution, and that is studied in this paper, Lohot and Dixit 24. It is sent for possible publication. And henceforth, I will be referring this distribution as SSLUD. So its PDF is as follows, SSLUD PDF. Gx is equal to 0 if x by mu is less than minus 1. It is this function for minus 1 to plus 1 if x by mu lies between this. And if it is e raised to minus mod x if x by mu is greater than or equal to 1, where mu is single parameter space is except 0, mu can take all values on the real line. Now, from this PDF, it is clear that the form of this PDF is different for mu positive and mu negative. So for mu positive, here is the CDF, corresponding CDF, capital GX. And similarly for mu negative, CDF will be little different. Now, the properties of this SSLUD, they are studied in our paper, Lohot Dixit. Those properties are discussed, are following properties: MGF characteristic function, first 4 raw moments, mode, median, hazard rate function, mean deviation about A, Rayleigh entropy and Shannon entropy, etc. Estimation of this single parameter mu is also discussed. 2 classical methods, method of maximum likelihood and method of moments. It is seen that no closed form expressions are available for this. Method of moments is estimator is obtained by solving the nonlinear equation, and MLE is obtained by numerically maximizing the likelihood. Hence, to study the finite sample and asymptotic properties, we have to use the simulation. Now, application of this distribution to real life data is also discussed in that previous paper, that transformed daily percentage change in the price of NIFTY 50 and Indian stock market index. Comparison of this distribution is also shown in that paper with standard distributions, normal, Laplace, and skew Laplace. And it is seen that the SSLUD mu distribution is well fitted to this data. Now, here is in this today's topic, or in this next paper, we discuss here test for symmetry of this distribution and the confidence interval for the parameter mu. Now, from the PDF form, it is clear that if 1 by mu equal to 0 in that GX PDF, then the SSLUD becomes standard Laplace, means it becomes symmetric distribution. Hence, we construct the most powerful test for testing this symmetry. So if this test is, as usual, this is the general format, phi AX, it is shown here. This is the test. And it is a most powerful level alpha test. For H0, 1 by mu equal to 0 against mu equal to mu1 positive, then it is positive skewness. If mu1 is less than 0, then it is negative skewness, where the test statistic is as follows. Test statistic critical values and power is studied as follows. this is the test statistic lambda AX. A for this H alternative hypothesis is mu positive. So these YIs which are mentioned in this statistic, they are order statistics. So this is a test statistic which takes the form if the minimum Y1 is minimum, sample minimum is less than minus mu1, then it is 0. If sample minimum is minus mu1 to mu1, if it lies in this range, then this form. And if it is greater than mu1, then it is 2 raised to n. So, and in the indicator function which is mentioned in this previous test statistic, it is 1 if yi observation is between minus mu1 to plus mu1 and 0 otherwise. Now we have studied its critical values and power of this test, of course using the simulation because the test distribution of a test statistic lambda is difficult to obtain. Hence we use this, hence we find the cutoff points, that is critical values, and compute the power of this most powerful test using simulation. So those two algorithms we have written, algorithm 1 to find the cutoff points and algorithm 2 to find the power of this MP test. And it is shown that from the tables, I am not presenting here the tables, but it is seen that of course, since it is a MP test, it has to be consistent, but it is proved from the tables that as the sample size n increases, power of the test increases. So it is a consistent test. Further, for fixed value of sample size n, the power increases as mu1 approaches to 0. Approaches to 0 means as mu1 may be positive or negative. For towards 0, when that value of mu1 goes, then the power increases. Of course, it is seen that since it is a MP test and for this distribution there is no sufficient statistic, the entire sample is sufficient for the single parameter mu. The same test is not UMP, so UMP test doesn't exist. Only MP test is whichever we have constructed. Now, we have discussed about the confidence interval of the parameter mu. So we use here two methods. Method 1 is assuming asymptotic normality of the MLE. So for SSLUD, as I mentioned, the parameter mu is its MLE is not in closed form, but we have to find it by numerically maximizing the likelihood function. So as we know, the nice property MLE has, it is asymptotically unbiased, consistent, and of course we have to check the regularity conditions. But here this family of distribution, it has the range of the random variable depends on the parameter. So it does not satisfy the regularity conditions. But from the tables in the earlier paper, we have checked all these conditions. Conditions means it is seen that the estimator MLE is asymptotically unbiased. It is consistent and it is asymptotically normal also. We have seen that histograms for large sample n, how it approaches to normal. So we assume the asymptotic normality of the MLE, and using this thing, we construct the confidence interval. That is first method. And second method is we construct the confidence interval for mu using the empirical distribution of mu. So algorithm 3 is for construction of confidence interval, CI, and algorithm 4 is to compute average length and coverage probability of this confidence interval. So to validate this procedure and for the comparison purpose of two methods, we compute the average length and the coverage probability of these confidence intervals. So this is regarding the method 1, which is based using the asymptotic normality of the MLE. Further, we also construct the confidence interval deleting the extreme value, that is outliers, and based on the remaining observations, and we see whether it improves or how it is useful or not. So these two algorithms, algorithm 3 and algorithm 4, and these are given here the steps. And these are given here the steps. And algorithm 3 and algorithm 4, they are based on the remaining observations, and we see whether it improves or how it is useful or not. So these two algorithms, algorithm 3 and algorithm 4, these are given here the steps. And these are given here the steps. It is the R code is written for this algorithm, and these tables are prepared for this. And it is seen that it has a nice performance in terms of the average length and the coverage probability. So algorithm 3 and algorithm 4. Algorithm 4 is for the coverage, average length and coverage probability. And now the next method, that is method 2, is by using empirical. Empirical distribution means, for example, if we generate capital N number of MLEs, then the n into alpha by 2th and 1 minus alpha by 2 into nth ordered value of the MLE of mu, this will be the confidence interval for mu. So if n is 1000, 25th value and 975th value, ordered value of mu hat, this interval will be our confidence interval for 95% confidence interval. So this we say that it is using the empirical distribution. So for using this method, we have done it. For this, there are two algorithms, algorithm 5 and algorithm 6 for construction of confidence interval, and algorithm 6 is to compute average length and coverage probability. Here also again, modified confidence interval is constructed, removing outliers using the interquartile range method, and then it is seen that tables are prepared for this for various values of sample size, original sample size, and the capital N is the we can say simulation size,